Good morning all. In the last class we have studied about the working of DC generator, that when the magnetic poles are stationary and the armature is the rotating part of DC generator, and when the prime mover gives the mechanical energy to the shaft of armature starts rotating, and this is the rotating part. And the magnetic poles are used to produce magnetic flux lines. And when the armature starts rotating, there is armature winding which is placed on the slots of armature, which cuts this magnetic flux lines, and it induces an EMF in it according to Faraday's law of electromagnetic induction. And the produced EMF is alternating one, so to convert it into DC, we use commutator segments, and which is converted into DC, and DC current is collected through brushes connected on the commutator segment. Okay, so here we need the magnetic flux. In DC machines, the required magnetic field is produced by electromagnets. It is not permanent magnets. Usually we use electromagnets. Electromagnets produce magnetic flux when a current is circulated through the field winding. Okay. Electromagnets means it will not produce magnetic flux lines within it. We have to give an excitation to that poles. നമ്മൾ ഈ ഒരു വൈൻഡിങ് പ്ലേസ് ചെയ്തിരിക്കുന്ന വൈൻഡിങ്സിലെ ഈ പോളിൽ പ്ലേസ് ചെയ്തിരിക്കുന്ന വൈൻഡിങ്സിനെയാണ് ഫീൽഡ് വൈൻഡിങ്സ് എന്ന് പറയുന്നത്. So the windings which is placed on the field magnetic poles to produce magnetic field, we are using some windings on the magnetic poles which is known as field winding. Okay, so electromagnets means it produces magnetism only when current is passing through these coils. Okay, so electromagnets produce magnetic flux when a current is circulated through the field winding. This circulation of current through the field winding of DC generator for producing magnetic flux is called excitation. അങ്ങനെ കറണ്ട് ഫ്ലോ ചെയ്യുമ്പോൾ മാഗ്നറ്റിക് ഫ്ലക്സ് പ്രൊഡ്യൂസ് ചെയ്യുന്നതിന് നമ്മൾ പറയുക, ഇൻ ഇലക്ട്രിക്കലി നമ്മൾ പറയുക എക്സൈറ്റേഷൻ, മാഗ്നറ്റിക് എക്സൈറ്റേഷൻ എന്നാണ്. ഓക്കെ, when the magnets are excited means it produces magnetic flux in the field in the air gap. Okay, so ഒരു ഈ കോയിലൂടെ കറണ്ട് പാസ് ചെയ്യുമ്പോൾ മാത്രമാണ് ഈ മാഗ്നറ്റ്സ് എക്സൈറ്റഡ് ആയിട്ട് മാഗ്നറ്റിക് ഫ്ലക്സ് പ്രൊഡ്യൂസ് ചെയ്യുക. നമ്മൾ കറണ്ട് റിമൂവ് ചെയ്ത് കഴിഞ്ഞാൽ it becomes zero, but there will be some magnetism will retain in the magnetic poles that we will study in later. Okay, നമ്മൾ പറഞ്ഞു ഇത് പെർമനന്റ് മാഗ്നറ്റ് അല്ല, ഇറ്റ് വിൽ നമ്മൾ കറണ്ട് കൊടുക്കുമ്പോൾ മാത്രമാണ് ഈ മാഗ്നറ്റ്സ് magnetism, property of magnetism expose ചെയ്യും, and also it excited and it produce the magnetic flux lines. When the current removes, the magnetic excitation also removes, so it reduces the magnetic flux, but it will retain some magnetic property within the magnet. Okay, അങ്ങനെ ഒരു പ്രോപ്പർട്ടി ഉണ്ട്, അത് നമ്മൾ പഠിക്കും. അതിനെ റെസിഡുവൽ മാഗ്നറ്റിസം എന്നാണ് പറയാം. Okay, so the generators are mainly classified according to the way in which their fields are excited. Okay, so now we are going to study about different types of DC generators, and with the classification is on the basis of how the field windings are excited. Okay, ഫീൽഡ് വൈൻഡിങ്സ് എങ്ങനെയാണ് എക്സൈറ്റ് ചെയ്യുന്നതെന്നുള്ള ഡിഫറെൻറ്റ് മെത്തേഡ് വെച്ചിട്ടാണ് നമ്മൾ ജനറേറ്ററിനെ മെയിനായിട്ട് ക്ലാസിഫൈ ചെയ്തിട്ടുള്ളത്. ഓക്കെ, നൗ classification of DC generators. Mainly DC generators are classified into separately excited generator and self-excited generator. Okay, this separately excited generator എന്ന് പറഞ്ഞാൽ in which the field winding is excited by a DC source, external DC source. Okay, ഒരു നമ്മുടെ ജനറേറ്ററിൽ നിന്ന് എടുക്കാതെ പുറത്തുനിന്നൊരു ഒരു എക്സ്റ്റേണൽ DC സോഴ്സ് കണക്ട് ചെയ്തിട്ടാണ് നമ്മൾ ഫീൽഡ് വൈൻഡിങ്ങിലോട്ട് കറണ്ട് കൊടുക്കുന്നത്. അതുകൊണ്ടാണ് അതിനെ സെപ്പറേറ്റ്ലി എക്സൈറ്റഡ് DC ജനറേറ്റർ എന്ന് പറയുന്നത്. That means field magnets are excited from an independent external source of DC current. Okay. Now, self-excited DC generator means the field magnets are excited by the current produced by the generator itself. Okay. So, self-excited DC generator means field magnets are excited by the current produced in the generator itself. Generator produced in a current തന്നെ യൂസ് ചെയ്തിട്ടാണ് അതിൻ്റെ മാഗ്നറ്റിക് ഫീൽഡിലൂടെയും ഫ്ലോ ചെയ്യുന്നത്. ജനറേറ്ററിൽ ഇറ്റ്സെൽഫ് പ്രൊഡ്യൂസ് ചെയ്യുന്ന കറണ്ട് തന്നെയാണ് ഫീൽഡിലൂടെയും ഫ്ലോ ചെയ്യുന്നത്. അപ്പോഴാണ് അത് എക്സൈറ്റഡ് ആവുന്നത്. ഓക്കെ. ആൻഡ് നൗ these are the main classifications: separately excited and self-excited. And the self-excited DC generators are of three types: mainly series wound generator, and shunt wound generator, and compound wound generator. Okay. In which first we are going to study about series wound generator. Series wound generator means the field winding is connected. We represent the field winding as a small winding. Okay. In electrically, when we draw the circuit diagram, the windings are represented like this. Armature is represented like this. Okay. When armature is represented like this. Okay. We know that armature is a cylindrical cylinder. So the brushes are connected to the commutator segment. So symbolically, we wrap electrical symbol of armature is like this. Okay. And winding, field winding is represented like this. Then, now first we are going to study about series wound generator. In series wound generator, field windings are connected in series with the armature. Okay. Field windings are connected in series with the armature. Okay. That means field winding is represented like this and armature is connected in series with that. ഇങ്ങനെ ഒരു കണക്ഷനെയാണ് സീരീസ് വൗണ്ട് ജനറേറ്റർ എന്ന് പറയുന്നത്. ഫീൽഡ് വൈൻഡിങ് അതിന് ആർമേച്ചറിന് സീരീസ് ആയിട്ട് കണക്ട് ചെയ്യും. നമുക്കറിയാം സെൽഫ് എക്സൈറ്റഡ് ജനറേറ്റർ എന്ന് പറഞ്ഞാൽ ആർമേച്ചറിൽ പ്രൊഡ്യൂസ് ചെയ്യുന്ന കറണ്ട് തന്നെയാണ് ഫീൽഡിനെ എക്സൈറ്റ് ചെയ്യാൻ ഉപയോഗിക്കുന്നത്. അപ്പം ആർമേച്ചർ വൈൻഡിങ്ങിന് സീരീസ് ആയിട്ടാണ് ഫീൽഡ് വൈൻഡിങ് കണക്ട് ചെയ്യുക. സോ that is series wound generator. Next one is shunt wound generator. Shunt wound generator. Shunt wound generator means the field windings are connected in parallel with the armature. That means the field winding is connected in parallel with the armature. Armature winding field winding parallel ആയിട്ടാണ് കണക്ട് ചെയ്തിട്ടുള്ളതെങ്കിൽ അതിനെയാണ് നമ്മൾ shunt wound generator എന്ന് പറയുന്നത്. Okay. And another one is compound wound generator. Compound wound generators are of two types: short shunt and long shunt generators, in which it has both shunt field winding and series field windings. Compound wound generator means it consists of both the series and shunt field winding. Okay. That means ഒരേ ജനറേറ്ററിൽ തന്നെ ഒരു സീരീസ് ഫീൽഡ് വൈൻഡിങ്ങും ഉണ്ടായിരിക്കും, ഷണ്ട് ഫീൽഡ് വൈൻഡിങ്ങും ഉണ്ടായിരിക്കുന്നതിനെയാണ് കോമ്പൗണ്ട് വൗണ്ട് ജനറേറ്റർ എന്ന് പറയുന്നത്. ഇൻ വിച്ച് ഷോർട്ട് ഷണ്ട് ജനറേറ്റർ മീൻസ് ഷണ്ട് ഫീൽഡ് വൈൻഡിങ്ങിന്റെ കണക്ഷൻ ആണ് ഇതിൽ ഡിഫറൻസ് ഉണ്ടാവുള്ളൂ, ഷോർട്ട് ഷണ്ട് ആൻഡ് ലോങ് ഷണ്ട് എന്ന് പറയുന്നത്. വെൻ യു ജസ്റ്റ് imagine this is the armature winding, and when the shunt field winding of this compound generator is parallel to only to the armature, and the field winding is connected like this, and the load is represented, the load resistor is represented by a rectangle box like this. So this one is shunt field winding, and this winding is series field winding. Okay, and this one is armature. This one is load. Okay. So shunt field winding is connected only to in parallel with the armature, and the series field winding is connected like this. So the load current will flow through series field winding. This connection is known as short shunt generator. In long shunt generator, there is only difference is this winding. Shunt winding is parallel to, I'll draw here, shunt winding is parallel to both of the series field winding and armature. Okay. And the load is connected in parallel with the circuit. Okay. ഇങ്ങനെ വരയ്ക്കുന്നതിനാണ്, അതായത് ജസ്റ്റ് ഈ ഒരു കണക്ഷൻ മാത്രം ചേഞ്ച് ചെയ്ത് ഇങ്ങോട്ട് വരുന്നുള്ളൂ. അതായത് now shunt field winding is connected in parallel with the series field and armature winding. Then we call it as long shunt generator. Okay. So these are the different types of DC generators. So mainly it is classified as separately excited and self-excited. So first we are going to study about separately excited DC generator. Okay. How the current is flowing through separately excited generator and the EMF equations. We are going to study about this. And here you can see this is a separately electrical circuit diagram of separately excited DC generator. Now, the field winding F1, F2. F1, F2 എന്ന് പറയുന്നതാണ് നമ്മൾ ഫീൽഡ് വൈൻഡിംഗ് ആയിട്ട് മാർക്ക് ചെയ്തിരിക്കുന്നത്. Okay, which produces main flux is energized by an external source of voltage, VF. You can see a VF voltage here. That is the voltage, external voltage which is connected to field winding to produce excitation. Field winding excite ചെയ്യാൻ വേണ്ടി കൊടുത്തിരിക്കുന്ന external voltage ആണ് VF, and the current flowing through this field winding is denoted as IF. And a resistor, variable resistor, is used to control the resistance. The resistance of field winding is RF. Internal resistance of field winding is denoted as RF, but here R is different. R is a variable resistance which is used for controlling the voltage. Okay. And EG is the generated EMF in the armature. Generator produce ചെയ്യുന്ന EMF നെ നമ്മൾ EG എന്നാണ് denote ചെയ്യുക. Okay. And armature is denoted by the term A1, A2. A1, A2 എന്നാണ് നമ്മൾ സ്റ്റാൻഡേർഡൈസ്ഡ് ആയിട്ട് ആർമേച്ചറിനെ മാർക്ക് ചെയ്യുക. ആർമേച്ചർ വൈൻഡിങ്ങിന്റെ 2 ends മാർക്ക് ചെയ്യുന്നതാണ് A1, A2, the fresh connections. Okay. The resistance of the armature, internal resistance of the armature winding is RA. ഈ RA എന്ന് കൊടുക്കുന്നത് വൈൻഡിങ്ങിന്റെ റെസിസ്റ്റൻസ് ആണ്. ആർമേച്ചർ വൈൻഡിങ് റെസിസ്റ്റൻസ് is RA, and the load current is IL. Load current is IL. Okay. Now, for separately excited generator, what will be the current flowing through the field winding? IF. IF is the current flowing through this field winding, and by Ohm's law we know that I is equal to V by R. So current IF is this voltage divided by total resistance. Here there are two resistance. One is R and one is internal resistance of field winding. So IF is, we can write as VF divided by R plus RF. Okay. Now armature current. Another current. What is the value of this armature current coming from the generator armature? IA. The current produced in the armature is IA, which is always equal to the load current. There is no another circuit. It's a single loop. So the current flowing through armature is same as the current flowing through load. Okay. Now we we have already studied the EMF equation. Eg is equal to 5Zn P by 60A. That is the EMF equation. So sometimes we don't know what is the flux, what is speed. So at that time we can find out the generated EMF by this equation. Generated EMF of this generator, DC generator, separately excited DC generator is V. If we know the output voltage V, the output voltage plus drop in that armature. We know the armature winding resistance is RA. So voltage, there will be some voltage drop due to resistance of armature winding. That is IA into RA, current. Voltage drop നമ്മൾ IR എന്നാണ് denote ചെയ്യുക. So ഇവിടെ current in armature is IA and resistance of armature is RA. So IA, RA is the voltage drop in armature, and there will be some voltage drop due to brush contact. So that is represented as V brush. Brush contact drop in volt. That is V brush, and IA, RA is the voltage drop in armature. So these are the equations which we can write in a separately excited DC generator. So separately excited DC generator means the field is excited by an external DC source VF, and the current flowing through this field winding is IF is equal to VF by R plus RF, and armature current is same as load current, and EG is V plus IARI. IARI is the voltage drop in armature, and V brush plus V brush, that is brush contact drop in volt. And next one is, now we are going to study about self-excited DC generator, in which first one DC shunt generator. Okay. So DC shunt generator, in which you can see the shunt field winding is connected in parallel with the armature. Okay. So the field winding, it is represented by F1 and F1, F2, which produces main fluxes energized by connecting it in parallel to the armature. Therefore, the full generated voltage is applied across field winding. So full generated voltage EG is applied across this winding because it is connected in parallel. So the resistance of field winding is represented by RSH. Shunt field winding ayadonde we represent the resistance of field winding as RSH, and the current flowing through it is represented as ISH. Shunt field current is represented as ISH, and EG is the armature EMF generated in armature A1, A2. Always represent the two armature winding points as A1, A2. And resistance of armature is RA. Output of armature is collected through 2.782, and the resistance of armature winding is denoted as RA, and the current flowing through it is IA, and the load current is IL. Okay. Load current flowing to this load is IL. Now, what are the equations coming in this DC shunt generator, which is represented by ISH? What is shunt field current? Just look, what is shunt field current? Shunt field current is, we know that EMF is generated here at the armature. So a current will come from the armature, that is IA, and that current is going, a part of that current goes to shunt field winding and one goes to load. So this one ISH is, what is ISH? If we know this voltage V, this is a parallel circuit, so voltage will be same. So V is the voltage across shunt field winding also, that is V. So V by current flowing through our field winding is ISH. So ISH is equal to, we know that the equation of current is I is equal to V by R. So here the terminal voltage is V. So V by, and the winding resistance is represented as RSH. So shunt field current is represented as V by RSH. And what is the current IA? We have already told the total current produced in armature, a part of current goes to shunt field winding and a part of current goes to load. So it is sum of ISH plus IL. And the generated EMF equation in terms of terminal voltages, the output voltage plus drop in armature plus brush contact drop. So you will get the generated EMF by using this equation. Okay. അതായത് ഔട്ട്പുട്ട് വോൾട്ടേജ് അറിയാമെങ്കിൽ ഔട്ട്പുട്ട് വോൾട്ടേജ് or terminal voltage plus drop coming in this will get the generated EMF. We know that generated EMF, the full generated EMF will not get at the as a terminal voltage. കുറച്ച് ഡ്രോപ്സ് ഉണ്ടായിരിക്കും. ഫസ്റ്റ് ഡ്രോപ്പ് എവിടെ വരുന്നത്? ആർമേച്ചർ വൈൻഡിങ് റെസിസ്റ്റൻസ് RA പ്രസന്റ് ആയതുകൊണ്ട് അവിടെ RA ഡ്രോപ്പ് ഉണ്ടായിരിക്കും. ദെൻ ബ്രഷ് കോണ്ടാക്ട് ഡ്രോപ്പിന് കുറച്ചൊരു പാർട്ട് കോൺട്രിബ്യൂട്ട് ചെയ്യും. അപ്പോൾ ബാക്കി വരുന്നതാണ് ടെർമിനൽ വോൾട്ടേജ് ആയിട്ട് നമുക്ക് കിട്ടുന്നത്. സോ EG is equal to that terminal voltage plus all of the drop. Next one will be shunt. In a self-excited generator, it is classified as DC shunt generator, then DC series generator. So next one is series generator. So in which the series field winding S1, S2, which produces main flux, is energized by connecting it in series with the armature. Okay, armature series ആയിട്ടാണ് series field winding connect ചെയ്യുക. The resistance of field winding is represented here. It is by RSE. Series ആകുമ്പോൾ നമ്മൾ SE എന്നാണ് ഫീൽഡ് വൈൻഡിങ്ങിന്റെ റെസിസ്റ്റൻസിനെ ഡിനോട്ട് ചെയ്യുക. And the current flowing through it is armature current IA തന്നെയായിരിക്കും, because it is connected in series. So current coming from the armature itself flowing through the series winding IA തന്നെയാണ്. And EG is the generated EMF on A1, A2. And the resistance of armature is denoted by RN and the load current is IN. And now we can write the equations of a DC series generator. That is, first one, what is armature current? Armature current produced in armature which is flowing through series winding resistance and to the load. Both are in series. So IA is equal to, in series winding, series connection, current will be same, voltage will be different. So IA is equal to, I series is equal to I load current. We can say that armature current is equal to series field winding current, and which is equal to load current. And generated EMF EG is V plus voltage drop in armature as IARA, and voltage drop coming due to resistance of field winding, that is IA into R series plus brush contact drop. So ഇവിടെ വരുന്ന total drops എന്തൊക്കെയാണ്? One voltage drop present in generator armature and a drop present in series field winding and a drop present in brush contact. So total generated EMF is terminal voltage plus IRA plus IR series plus V brush. Okay. Then next one is these are the difference between shunt and series generators. According to the connection, what are the difference? The field winding is connected in parallel in a shunt generator. In series generator, field winding is connected in series. And the current in field winding, how much is the current in field winding? A small current which is about 10% of armature current is flowing through the shunt field. Okay. Because of that, the large number of turns is used, and it will be a thin wire, and also it has high resistance. Shunt field resistance at a higher value. Okay. And large current which is equal to armature current will flow in the DC series generator, because series field winding is connected in series with the armature. Whole of the armature current will flow through series field winding. So it has only few turns and are having thick wire. Okay. Then resistance of field winding large in a shunt generator. Resistance of series field winding small ആയിരിക്കും. Okay, and variation in field current is almost constant from no load to full load. In a shunt generator, field current is ISH എന്ന് പറയുന്നത് ഒരു constant value ആയിരിക്കും. But in series generator, field current varies with change in load ആയിരിക്കും. അപ്പോൾ ഒരു constant field current ഉണ്ടായിരിക്കുക shunt field winding and series field winding variable current ആണ് ഉണ്ടാവുക. Then next one is compound generator, in which first one is short shunt type compound generator. Here you can see the shunt field winding is connected in parallel with the armature alone. You can see the shunt field winding is connected in parallel to the armature alone, and the series fielding is connected like this. In short shunt type compound generator, the shunt field winding F1, F2 is connected only across the armature, and the series field winding is connected in series with the parallel combination of armature and shunt field winding. Okay, the current in series field winding is equal to load current because it is connected in series to the load. So current in series field winding is equal to load current. Here the produced armature current on the armature winding is one part is going to shunt field winding, one goes to series field winding. So we can say IA is equal to ISH plus IL. And what is the shunt field current ISH? That is, I'll clear it and explain. ISH is the current flowing to shunt field winding. Here the whole V will not be the voltage across this winding. There will be some drop here in the series field winding. So we can represent the voltage across this is V dash. Voltage across this armature or voltage across this shunt field winding as V dash, which will not be equal to V because there is a drop coming on the series field winding. So V dash by RSH. What will be V dash? V dash is terminal voltage plus drop in the series winding IL R series. That is V dash. Then generated EMF. നിങ്ങൾക്ക് മനസ്സിലായെന്ന് വിചാരിക്കുന്നു. ഷണ്ട് ഫീൽഡ് വൈൻഡിങ് ഈ ഒരു കറണ്ട് കണ്ടുപിടിക്കാൻ, ഷണ്ട് ഫീൽഡിലെ കറണ്ട് കണ്ടുപിടിക്കണമെങ്കിൽ ഇവിടെ ഉള്ള വോൾട്ടേജ് അറിയണം, ഷണ്ട് ഫീൽഡിന് അക്രോസ് വരുന്ന വോൾട്ടേജ്. And we know that I is equal to V by R. So this voltage divided by shunt field resistance will get the ISH. Okay. പക്ഷെ ഈ വോൾട്ടേജ് കിട്ടാൻ എന്ത് ചെയ്യണം? നമുക്കറിയാവുന്നത് ടെർമിനൽ വോൾട്ടേജ് ആണെന്ന് വിചാരിക്കാം. ഈ V കറക്റ്റ് ഇതിന് പാരലൽ അല്ല, ഇവിടെ ഒരു വൈൻഡിങ് വരുന്നുണ്ട്. അതുകൊണ്ട് V പ്ലസ് ഡ്രോപ്പ് ഇൻ ദാറ്റ് സീരീസ് ഫീൽഡ് വൈൻഡിങ് കൂടെ കൺസിഡർ ചെയ്യണം. അതായത് IL ഓർ I സീരീസ് എന്ന് പറയുന്നത് സെയിം തന്നെയാണ്. IL R സീരീസ് ഈ ഒരു ഡ്രോപ്പ് കൂടെ കൺസിഡർ ചെയ്ത് കഴിഞ്ഞാൽ വോൾട്ടേജ് അക്രോസ് ആർമേച്ചർ ഓർ വോൾട്ടേജ് അക്രോസ് ഷണ്ട് ഫീൽഡ് റെസിസ്റ്റൻസ് കിട്ടും. ഓക്കെ, so this will be V dash. Then IARA, what is generated EMF? Generated EMF is EG produced in this is, ഇവിടെ എന്തൊക്കെ ഡ്രോപ്പ് ഉണ്ടായിരിക്കും? ഔട്ട്പുട്ട് വോൾട്ടേജിന്റെ കൂടെ ഏതൊക്കെ ഡ്രോപ്പ് ആഡ് ചെയ്താലാണ് ജനറേറ്റഡ് EMF ആവാന്ന് നോക്കാം. V plus terminal voltage V plus, we know that the drop present in armature is IARA, voltage drop in armature, and there is a winding series field winding, so IL R series, and brush voltage drop, brush contact drop. ഈ മൂന്ന് ഡ്രോപ്പ് കൂടെ ആഡ് ചെയ്ത് കഴിഞ്ഞാൽ ടെർമിനൽ വോൾട്ടേജിന്റെ കൂടെ ആഡ് ചെയ്ത് കഴിഞ്ഞാൽ we will get EG. Okay, then next one is long shunt type compound generator. In long shunt type compound generator, you can see the shunt field winding is connected in parallel to both of the series field winding and armature. Okay, in long shunt type compound generator, the series field winding S1, S2 is connected in series with the armature. S1, S2 is connected in series with the armature. And the shunt field winding F1, F2 is connected across the series combination of armature and series field winding. So what will be the equation of this armature current? Armature current is the current coming from the armature, which is equal to a part is goes to shunt field winding and part is goes to load. So ISH plus IL is the armature current. And what is shunt field current? ISH. ISH is, here you can see the voltage across this load will be same as the voltage across our shunt field winding. So we can write it as V by RSH. And the generated EMF is EG on this armature is calculated by this output terminal voltage V plus drop in armature plus drop in series field winding. So V plus IARA plus IAR series plus, and also we have to consider brush contact drop. Okay, so you will get EG. So these are the classifications, and another one classification as a compound generator is cumulative compound generator and differential compound generator. In cumulative compound generator means generally shunt field winding. In a compound generator, generally shunt field winding is stronger than series field winding. So if the series field and shunt field are in the same direction, magnetic field produced in series field winding and shunt field winding are in the same direction, then we call it as an additive field, or both the field are additive to each other. Then the generator is said to be cumulatively compound generator. Okay, നമ്മൾ രണ്ട് വൈൻഡിങ്സ് ഉണ്ട് കോമ്പൗണ്ട് വൗണ്ട് ജനറേറ്ററിൽ, സീരീസ് ഫീൽഡ് ആൻഡ് ഷണ്ട് ഫീൽഡ് വൈൻഡിങ്. രണ്ടിലും പ്രൊഡ്യൂസ് ചെയ്യുന്ന മാഗ്നറ്റിക് ഫീൽഡ് സെയിം ഡയറക്ഷനിലാണ് എങ്കിൽ അത് രണ്ടും കൂടെ ആഡ് ആവുകയാണ് ചെയ്യുക. സോ ദ ടോട്ടൽ മാഗ്നറ്റിക് ഫീൽഡ് വിൽ ഇൻക്രീസസ്. That type of generator is known as cumulative compound generator. On the other hand, if series field opposes the shunt field, series field shunt field in opposite ആയിട്ടാണ് പ്രൊഡ്യൂസ് ചെയ്യുന്നതെങ്കിൽ, then that generator is said to be differentially compounded generator. Okay, thank you. These are the different classifications of DC generator.